Hi. Alright guys, so this is the video I'm going to upload to explain the vertical throw. Okay, so first I have to tell you some things, okay, about the vertical throw. Remember that the vertical throw, well, in the vertical throw, the initial speed is equal in magnitude to the final speed when it reaches the ground. I mean, the initial speed when it goes up is equal to the final speed when it goes down, but in opposite direction. So the one that is going to the ground is negative. Okay. Also, you all have to know that the speed in the highest point of motion is zero. Okay. So after I tell you this, I have to tell you this too. Vertical throw is basically the same. Well, you have to do basically the same things as the ones that you do on the free fall. Okay. You actually use the same formulas, and one part of that of this kind of problems is equal. Okay, so now I'm going to explain you this problem. Okay, the problem goes like this. It says an object is thrown upward with an initial speed of 30 meters per second. Calculate the time, well, A, the time it took to reach the highest point, B, the maximum height reached, and C, the total time of the flight. Okay, so this is what I'm going to explain you now. I already have here the situation. Okay, so this is the situation. I have a person who's throwing something, an object, can be a ball, upward. So that ball will get to the highest point and it will go down again. Okay, all this occurs with this initial data you have, the speed of launching, this the initial speed when it goes up, that is 30 meters per second. Okay, so after I told you this, remember I just told you this. The speed in this position is zero. Okay, so we can take this zero as the final speed when it goes up or the initial speed when it goes down. Okay, it doesn't matter how you want to have it, that zero is already there. Okay, so this is important because to calculate the time, that is the first question you have, you need to understand it very well. Okay, because the time, you have a formula for the time where you have the speed. Okay, that is the final speed minus the initial speed divided by the time, the acceleration of the gravity. Okay, so as you have it like this, you know that the final speed when it goes up is zero and the initial speed is 30, and the acceleration of the gravity is always negative 9.8. So that's the way I'm going to do it here. Okay, so it's going to be equal to the final speed, which is 0 meters per second, and the initial speed, which is 30 meters per second. Okay, and I'm going to divide it by the negative 9.8 meters per square second. Right? So that will give me the time of 3.06 seconds. So until here, I already have the time, and I'm going to move on to the next question. What is the maximum height reached? To answer this question, guys, you have to know that there are two strategies. I'm going to explain one of them. Okay, that is the easiest one, is to imagine that this is a free fall when it reaches this point. When this object reaches this point, the motion starts at 0 meters per second, so it starts basically as a free fall. So you know that the object will take 3.06 seconds to fall. So it means that you can calculate it as it were the free fall problem that we did on another one of the problems. Okay, so you can calculate the height from it was dropped, let's say it like that. Okay, but you are actually going to be calculating the maximum height reached. Okay, so I will do it as it were the initial height, and it's the negative half of the acceleration of the gravity times the time interval squared. So you can do it like this. Okay, if you do it like this, then the initial height of the fall would be the negative half of negative 9.8 meters per square second times the time, that is 3.06 seconds square. Okay, and you'll get that is 45.88 meters. So here it is. Okay, is the negative half of negative 9.8 times 3.06 seconds square. You got this 45.88 meters. All right, so you already calculated here the height and the time it took to reach the maximum height. Now the last question, the total time of the flight. Remember that this time it's only the half, because the motion is to go upward and downward. Okay, and it is the same time in both cases. So what you are actually going to do here is just to multiply this by 2, and you will obtain the total time of the flight. Okay, so I'm going to write here the time of flight is the time, that is 3.06 seconds times 2, and you'll get that is 6.12 seconds. Okay, so this is the time, the total time of the flight, that is twice this, because it goes up and down, and this is the height that I calculated, taking in account that it fall during 3.06 seconds. So I can calculate it like this, as it was the free fall. That's all.